Today is on Monday, so Monday usually we'll share about the technical on the technical sharing. Today our topic will be selection guide of WAF metal seat. Okay, yeah. So first and foremost, what is a WAF seat? The WAF seat, WAF creates a sealing when the trim comes into contact with the seat. So as the example in the diagram below, I've used the ball WAF as an example. So basically the trim is a ball. Actually trim is more than ball. Trim and the stem is a sorry, the ball is the trim. The trim is the stem and the ball. So for this on the sealing element, basically it happens in between the ball and also on the seat. Why the selection of WAF seat is so important? Because WAF seat is the one will be affecting on the shut off capabilities. For this example, I'm using a ball WAF. The selection will be similarly happens in the butterfly WAF, the glove WAF, the plug WAF, and so on, as well as a gate WAF. Last week we have shared about the soft seat selection, and this week we'll continue it with the metal seat selection. This is an example on the sharing of last week. For example, on the elastomeric seal, for example, on the nitrile rubber NBR Buna N, basically the selection, one of the consideration is on the operating temperature. For NBR, the operating temperature is from 0 to 80 degrees Celsius. For the Yton, or we so-called FKM, is from -40 to 180 degrees. One moment, let me take into the. Okay, yeah, so you all can hear me. And for the category of the thermoplastic, for example, Teflon, the operating temperature is slightly more wider, from 80 degrees to 200 in -80 degrees to 200 degrees. For the nylon, from -20 to 100 degrees. Teflon, up to 100 degrees as well. And for the pig seat, we so-called the polyether ketone, is from -80 degrees to 160 degrees. The main concern of the soft seat, basically soft seat, it will achieve a better seat tightness comparing to a metal seat, but there's a limitation on the pressure and as well on the temperature. And today we'll introduce you or we'll share with you about the WAF coating or the WAF coating for the metal seat. What is the important criteria before selecting a WAF metal seat? First thing, when we are using a metal seat, it's actually a metal-to-metal contact in between the ball and the seat, as the example I've shared to you just now. Or for example, in the glove WAF, then it will be the WAF plug with the WAF seat. For butterfly WAF, then it will be the WAF disc with the WAF seat, and so on, so on. So it's basically it's applicable to all different of WAF types, but the criteria is very much more similar. For example, on the fluid temperature, on the operating temperature, if you're using on high temperature, for example, just now when we show about when PTFE can handle up to 200 degrees, if you're using higher than that, 300 degrees, 400 degrees, then we have to use a metal seat. As well as to the cryogenic services, for example, up to -496 degrees, then we have to use a metal seat. As well, it's actually comparing to the media, the fluid. If it's a very abrasive, it's a very corrosive, or it's a dirty fluid, then metal seat will be more prone to be prone on the damage and wear and tear. On the number third one, what is the maximum shut-off pressure, minimum and maximum of the operating pressure? It will be one of the important criteria for us to take into consideration when we are selecting either a soft seat and the metal seat. For metal seat, most of the time we are applying for the heavy duty application as well. For example, on the high cycle, because for the soft seat, the wear and tear will be more obvious. By using a metal seat, we can actually choose a good WAF coating or the hardness coating, which is it will prolong the durability. And the last one is on the chemical compatibility, which if soft seat or the thermoplastic material is not suitable. So why is it so important that we have to discuss about the metal seat or the trim coatings? Because a good selection of a trim coatings, it will provide you a smooth sliding and is a very durable, especially for your high cycle usage. Secondly, for a selection of a hardness value of the coating, it can actually minimize what you call on the trim damage and as well on the wear and tear. Also, it will minimize the gearing. And number fourth is actually it will reduce on the friction. Why reducing a friction, or why is a combination of a trim and seat, metal trim and metal seat is so important? Because by reducing the friction, you will actually require a lower WAF torque value, which resulting in you are actually needing a smaller actuator. So a smaller actuator means is improve the signal and response in the controlling, as well in the complete assembly, because on the smaller actuator then the weight will be smaller, will be lighter, and also it will simplify because if larger actuator then you will need a higher stroke volume. By using a smaller one, then you actually simplify the accessories required in order for you to meet to your cycle speed. For example, you don't need about the air operated valve or the quick exhaust valve and so on. And we also must consider, by selecting on the trim coatings, we also consider have the suitable base material, which is what is the base material we are using, because despite we are actually applying on the trim coating, some of the coating, I would say most of the coating actually there are still some porosity to some degree that is actually it will not effectively 100% isolate against the corrosive media or about your fluid. Okay, so this is below is some of the common coating application. I have listed out 5 here. Beforehand, any question? Let me take a look. Yeah, you can hear me good. Thank you. Yeah, Lincoln, thank you. Okay, let me continue. On the first one, electroplating. Is actually a wet containing chromic acid and sulfates or fluorides as catalyst. Basically, for this electroplating, we are using for the hard chrome and as well on the ENP lah, electrolysis nickel plated. I will talk more about that later. And secondly, thermal spray and fuse. So fuse in a vacuum furnace or by flame. This is actually there's some limitation for this method, which is it will be limited by the capacity of the furnace. For example, this will use for the nickel boron coating. And HVOF, very commonly we say, is a high velocity oxy-fuel applied as a powder combined, there's some typo error, combined with a high velocity jet of combustible gases. Basically, we are using this method for the carbide based coating, tungsten carbide for example, and the thermal diffusion. An element is the diffuse into the material surface to create a dense reaction zone with an increased surface hardness and resistant to wear and impact. So one of the so-called diffusion method. And the last one is a PTA, plasma transfer arc welding, welded to the substrate or we so-called the base material using either a powder or road consumable used to apply on cobalt-based alloy. This cobalt-based alloy, or commonly we will hear about a sterlite 6 coating. Yeah, so this is basically is the same thing for cobalt-based alloy. These are the some of the common examples I have extracted about the metal seed coating. The first one is HCl, we so-called the hard chrome or hard chromium. For hard chromium, the coating, the thickness usually is 0.05 to 0.1 in millimeter. For the hardness measurement, for the HRC, or we so-called hardness in Rockwell scale C, is 70, or the hardness in Vickers is 1000. The application method, which is electroplated, we mentioned just now for the hard chromium, we are using the electroplated application method, and the suitable substrates will be the stainless steels, nickel-based alloy. And secondly, on ENP, just now I mentioned about electroless nickel plating. The thickness it has to be a 0.06 as minimum, and the hardness value is slightly lower than the hard chrome, 68 in HRC and 950 in HV, hardness in Vickers. The method is similar to hard chrome, or we are using the electroplated method. The beauty of this ENP is we can actually using the carbon steel as a suitable substrate, which is at a lower cost. As well, of course, we can use it on the stainless steel and the nickel-based alloy. So the consideration on the using the carbon as a substrate is you have to consider what are the medium you're using for your application. And for the Nivo coating, or we so-called the nickel boron, the thickness is from 0.5 to 1 mm. The hardness is is lower comparing to the ENP and hard chrome. So 55 in HRC and measured 600 in HV. The method is we are using the S and F, which is we so-called it spray and fuse here. The substrate or the base material we can use is a CFAM stainless steel and tungsten carbide. Tungsten carbide is an expensive one. The thickness for this coating will be 0.1 to 0.15. You can see the hardness value is very similar to hard chrome. So it's about HRC 70 and the HV is measured in 1000. We are using the oxy-fuel method, HVOF, high velocity oxy-fuel. And the suitable substance will be stainless steel, nickel-based alloy. Another one is a tungsten chromium carbide. So tungsten carbide and tungsten chromium carbide. Both of the what do you call the characteristic is very similar as well to the substrates we can be used. And the last one on the chromium carbide, or usually we call it chrome carbide lah. The thickness will be 0.1 to 0.15 mm, and the measured hardness value in HRC, hardness Rockwell scale C, measured at 65, and hardness Vickers measured at 800 using the HVOF method, and the substrate is very similar. So how do we select in between these all these different coating? Yeah, of course, the last one is the cobalt-based alloy. We so call the what do you call? We so call on the sterlite 6. Yeah, so earlier we mentioned HVOF. We are using the PTA method as well, plasma transfer coating for the chrome for the cobalt-based alloy. Okay, let's get to the first one, which is on the hard chrome. So hard chrome basically is it's a very common one, especially in some of the more how to say a more common or standard offering for the so-called the metal seed lah. So it's suitable to be used in a clean fluid like a clean liquid and gases, but it's only limited to the moderate temperature and pressure. The pH value of the media, it has to be less than 2, and it has no resistance to, it's not suitable to be used with the chloride content and as well to the, it's not suitable to be used with the seawater, wet chlorine, or the higher chloride content. And the second one on the very similarly on the ENP, electroless nickel plated, is generally to be used as a substitute to the hard chrome, and it can be at a lower cost because we can opt for the carbon steel based material. Similarly, is it actually had a greater corrosion resistance comparing to the hard chrome, but the pH value for the media is still has to be less than 2, which is not suitable for the chloride content. And nickel boron. Nickel boron comparing to the hard chrome and ENP, nickel boron it can performs very well in high temperature and also a high pressure application. It also can suitable for the abrasive media and dry gases. But the as well as if it's actually not recommended to be used with the acid and also the wet chlorine. And just now we mentioned earlier is for the nickel boron we have a limitation because it will actually require a very big furnace. Otherwise, then there's a size limitation. Yeah, then we come to the premium one on the tungsten carbide. Tungsten carbide, yeah, over here then we can see there's a tungsten carbide and the tungsten chromium carbide. Tungsten carbide is very resistant on the very resistant from the wear and tear, and it's very suitable for the high cycle operation. So basically for those upstreams, for example, on the very abrasive catalyst, muds, slurries, then you choose tungsten carbide. Also, it's a very ideal for the cryogenic application, oxygen service as well. But it's for example, if you're using for water or condensate, it's actually still not encouraged. The temperature characteristic for this is also very good, but it's limited by the base material or the base material we are using. So similarly for the chromium carbide, or we so called tungsten chrome carbide, it also provide a very excellent resistance in the application. For example, comparing to tungsten carbide. So for tungsten chromium carbide is suitable to be used in the seawater or in organic acids, water, sour, what do you call sour service or sour and wet hydrocarbons, H2S. Also on the CO, yeah, basically it's a H2S services lah. So comparing to the tungsten carbide, if you're using for the sour service, we have to opt for the tungsten chromium carbide. And chrome carbide, or we so called chromium carbide, as well, comparing the differences comparing to the hard chrome. Chromium carbide is very suitable for high temperature gas and liquid application, and also has a very excellent resistance on the wear and tear. Similarly to erosion and corrosion, it also handle very well. So cobalt-based alloy, or we always so call the again sterlite 6. This is actually quite commonly used. We will not only apply on the seed material, we only apply on the shaft, on the bearing, and so on, in order to prolong on the life cycle of all those components. Okay. And lastly, after we talk about all these different type of coatings, this is actually some of the combinations we have selected. For example, on the ball, we are using the hard chrome, and the seat, we are using the cobalt-based alloy. These are suitable to be used in a temperature range of -50 to 450. It has a good corrosion resistance, better erosion resistance, suitable for the liquid, but it's not suitable for the dry gas, like we mentioned just now for the hard chrome. And the cost is, I just put one symbol, means it's quite economical. And similarly to ENP as well, ENP will be cheaper, but it has a lower corrosion resistance. Cheaper if you're using the carbon steel based material, especially on the ball and on the seat. So on the ENP ball, usually we use ENP only on the ball, and the seat we will still use back on the cobalt based alloy. So by using this combination, we have a very, we so-called the best corrosion resistance comparing to the hard chrome ball, and the price is also cheaper if you're using carbon steel based material. Erosion is good. On the nickel boron, so on the nickel boron with the cobalt based alloy, the temperature range we can actually extend it up to 600 degrees Celsius. Very good erosion, good corrosion, as well as is the comparing to the previous one is suitable to be used on the dry gas, but the cost is eventually higher by using the nickel boron. We also have another combination by using the Nebo ball and also the chrome carbide. LF is actually a low friction. Like just now I mentioned, by using the low friction, it will actually resulting a lower watt torque. Then you actually need a smaller actuator. Temperature range up to 600 degrees, but it's actually much more expensive comparing to the cobalt-based alloy. And the durability, of course, is better. That's why we are paying more on this one. And on the tungsten carbide, temperature up to 400 degrees, but it can actually suitable to be used on the cryogenic, which I mentioned just now, up to -200 degrees. Sorry. Uh, better corrosion resistant, better erosion resistant, not suitable for the liquid media, comparing to the tungsten chromium carbide, the next one. And the price for tungsten carbide is expensive. Yeah. And comparing to the next one, which is a tungsten chromium carbide combination for both the ball and seat, it can be used on the liquid media, or and what do you call, the corrosion resistance is good, and the price is, but it's not suitable for the dry gas. So basically, the differences between the tungsten carbide and the tungsten chromium carbide is you have to opt it according to if you're using a liquid or you're using for the gas services. And the last one I have it here is on the chromium carbide, and the chromium carbide low friction seat. The temperature range actually can, this is highest, can up to 800 degrees. It has a very good corrosion resistant, very good erosion resistant, can be used in liquid and can be used in gas as well. But the cost is also slightly less expensive comparing to the nickel boron ball. Yeah, but because if you can notice that actually we are changing the nickel boron ball to the chrome carbide ball, temperature range we extended, but the price is cheaper lah. So this is some of the example of the combination. Yeah, let me take a look in the comment. Now, from Wai Chong mentioned is what type of coating is suitable to be used for low temperature environment. I will assume that Wai Chong is actually asking for the low temp service lah. So for the low temp service, as we mentioned here, is you may notice, so they are like the nickel boron seat can be suitable to be used up to -200 degrees. Same to the tungsten carbide, and as well on the chrome carbide. So these are the selections suitable to be used in the cryogenic services, or we so-called in the low temperature service. This is actually more than low temperature lah. This is already in cryogenic services. Okay, yeah. So this is basically the common selection guide I would like to share today about the metal seat. So please stay tuned on our channel in our Facebook page for the more information on the next week onwards, and every Monday we will share about the technical sharing. Okay, so that's all for my sharing on today. Thank you. Sorry about the earlier technical error. Yeah, next time I will just engage and make sure on the setting is correct and good. Okay, thank you everyone. Bye bye.